Hello, everyone. I'm Haipeng Cai from Washington State University. Thanks to the organizing committee for accommodating people, including myself, who cannot attend in person. And thanks all for attending this talk. And so, in this short presentation, I will share my personal reflection on the predictive accuracy of dynamic impact analysis. And this is a JSS paper we published back in 2015 on this topic. After quickly introducing what the dynamic CAA is, I will be reflecting on how back then we believed how this work would be followed up, in contrast to how this work actually has been followed up later on. Then I will share my personal thoughts on justification of the contrast and envision some of the future steps on this topic. And we also know that changes are the driving force of software evolution, and during the software's evolving process, changes have to be analyzed concerning its potential impacts. And so it's critical to do change impact analysis or CAA technique. So among two classes of CAA techniques, static and dynamic ones, dynamic technique produces typically much smaller and there's more precise results than static analysis. Further, the CIA technique can be applied either after or before the change is made. When applied before the change, the analysis actually predicts the impact of potential changes. In our JSS paper, we focused on the predictive dynamic CIA technique. And this is the typical usage scenario of the CIA. It inputs the programs before the changes is made, which is called the base version of the program, and the candidate change locations, and outputs potential impacts of any change at those change locations. For example, suppose the program contains 5 entities, E1 through E5, and suppose the developer plans to change the entity E2. The technique may predict all the 5 entities, but E4 would be impacted by any changes at E2. But actually, the actual impacted entities are only E2 and E4. Let's suppose that's the case. So in this context, our question was that how safe is the result, which concerns about whether it included all real impacts, namely the impacts after the change is made. And another question is how precise is the result, which concerns about whether the entities in the result are those and that are really impacted. In short, we basically were asking how accurate is the analysis. And so what we did for the paper was that we presented a first experimental methodology for estimating the predictive and accuracy of dynamic CAA, and conducted, using this methodology, a comprehensive study of the accuracy with 2 state-of-the-art CAA techniques back then against different kinds of code changes. And we found that the static techniques were surprisingly inaccurate, with around only 50% recall and precision. Accordingly, we pointed out two lines of work as expected to be followed up by later research. The first line is about developing more accurate dynamic CAA techniques, for which we actually also shared some insights and recommendations on how to achieve that goal. For example, by combining various types of program information. And the other line is to look further into the performance, including effectiveness and efficiency of CIA techniques, possibly reusing our toolkit and experimental methodology. And looking back now, we noticed that there have been 2 lines of work that actually followed up the paper. The line of developing new CIA techniques, for instance, includes proposing a new solution by combining varied information retrieval techniques proposed by Wang, etc. in 2018. And there were also researchers citing our paper who developed more precise CIA techniques, for example, by leveraging the equivalence relationships or data sharing and calling dependencies to improve precision, among others. In particular, combining multiple types of dependencies to improve dynamic CAA accuracy is highly consistent with what we suggested as a general idea for improving the accuracy of CIA. However, we also noticed multiple gaps here. Among the first line of follow-up work, the authors who developed the new CIA techniques mostly cited our paper as their CIA technique, rather than using our empirical results for motivation. And, and even though, in fact, our paper did not focus on a new dynamic CIA technique, but rather on a comparative study. Even though we did develop a CIA technique, but that technique was descriptive and for the purpose of computing the ground truth for the evaluation purposes. Second, although there was follow-up work focusing on developing more precise CIA techniques, the later techniques are not dynamic CIA techniques. Finally, concerning our suggestion on conducting more comprehensive studies on CIA techniques, we did not find any follow-up work citing our work or not. So we believe one reason is the nature of dynamic CIA, which is a dynamic dependence analysis at the core, has not been well recognized. Another reason is possibly that the dynamic CIA may not be as intuitively applicable as the static approaches because it works with respect to particular program executions. However, for scenarios like regression testing and debugging, the focus is indeed on particular program executions. Yet another possible reason is that various approaches in this area might have already been well explored. So that makes it a little bit harder to push the boundary further. In fact, we see later work in the CIA area mainly looked at non-dependence-based or even non-code-based approaches, even though dependence-based CIA still secures a spot in the CIA taxonomy. And looking forward, we believe our dynamic CIA technique has potentials that have not been well exploited concerning its nature as a dynamic data flow analysis. Also, the experimental toolkits includes a technique for generating a large number of program variants at runtime. Our work also raised the awareness of the gap between user-perceived accuracy and the accuracy based on syntactic dependence analysis. Finally, we envision several future directions on advancing the area of dynamic CIA. For example, by leveraging developer knowledge to prioritize the resulting impact sets, showing the benefits of improved precision of dynamic CIA in the application analysis, not just focusing on improving the analysis precision itself. And finally, we also believe that the technique can be used for enabling varied incremental analysis that leverages dynamic impact set computed by the CIA technique. And with that, I would like to wrap up my short presentation here. Thank you a lot for all your time and attention to this talk, and I will be trying to answer any questions you may have. Thank you very much.